So now we are going to see the torque on a magnetic dipole, bar magnet in a uniform magnetic field. So first lesson la நம்ம charge பார்த்திருப்போம். அதே மாதிரி இப்ப என்ன பார்க்கறோம் அப்படினா magnetic பார்க்கறோம். magnet பாத்தீங்க அப்படினா north pole south pole. அங்க பாத்தீங்க அப்படினா positive charge negative charge இருக்கும். electric dipole ல இங்க magnetic dipole ல north pole south pole அப்படினு இருக்கு. So a magnetic dipole is placed in a uniform magnetic field. It experiences the torque because the two forces, that one force is acting in a here, that is positive MB, that one direction, that other direction is acting in a negative direction MB. So two equal forces acting in a opposite direction. So it constitutes a couple. So it experiences the torque. So torque tau is equal to magnetic force, any one of the force into perpendicular distance. So T equal to, so torque equal to M into, M means pole strength. So that is a magnetic force M into B, magnetic induction, any one of the force, because MB, the two sides are same. So you can take any one value MB into that length to a perpendicular distance N into this distance. This distance is equal to 2L sin theta. That you know that how we calculated that value. So MB sin theta. Here capital M is the magnetic dipole moment. Small m into that distance 2L. So multiply the two value, will get the dipole moment M. So MB sin theta will get torque tau is equal to M vector cross B vector. So this is a uniform magnetic field. And the next thing is the amount of work done or the potential energy. So here we know that already we calculated that value. The amount of work done is stored in the form of potential energy. Here the work done on a magnetic dipole, bar magnet in a uniform magnetic field, the amount of work done is dW is equal to torque tau into dt, d theta, because it is a rotational motion. So the amount of rotational motion is stored in the form of potential energy. So already we know that the same calculation. So torque tau equal to mb sin theta, substituted that value here, integrated that value from theta 1 to theta 2. So we will get that W equal to mb cos theta 1 minus cos theta 2. The potential energy is arbitrarily taken 0 when the dipole is at 90 degree. Then potential energy is rotating the dipole and inclining at an angle of theta is potential energy equal to minus mb cos theta. So இதில பாத்தீங்க அப்படினா first theta 1 equal 0 நமக்கு கொடுத்துருவோம். நம்ம cos 0 1 மத்த theta 1 equal 90 degree, அது நமக்கு தேவையில்லை. So from 90 degree அப்படிங்கிறது 0ங்கிறதுனால we calculated the value of 0 degree. That 0 degree means that magnet is aligned with the external field, electric external field. So it gains the maximum potential energy of minus mb cos theta. So now we are going to see the tangent galvanometer. So tangent galvanometer is an important question. So it's a 5-mark question. So now we are going to see the tangent galvanometer. Okay, right. Say that the tangent galvanometer is a device used for measuring the current. It works on the principle of tangent law. A magnetic needle suspended at the point where the two cross fields are right angles to each other. It will come to rest in the direction of resultant of two fields. So ரெண்டு field இருக்கு, cross field, ரெண்டு perpendicular இருக்கும். அந்த field ஒரு needle வச்சோம் அப்படினா it will come to rest in the direction of resultant. So it's made up of circular coil of wire. It's made up of brass or wood. It's a circular coil. It's made up of brass material or wood material. So this is called a tangent galvanometer. So 3 leveling screws are there. It is used to make the tangent galvanometer in a horizontal. And it's a vertical frame. That frame, you know that upright projection is inside the galvanometer. Above the galvanometer, the compass box is placed. Compass box means you know that it has a magnet, small pivoted magnet, and that perpendicular to that magnet it has an aluminium pointer. The two things are perpendicular to each other. Okay. Then circular scales are there. The reading values are from 0 to 90 degree. It is separated into 4 quarter parts. So total 360 degree, that is divided into 4 quarter parts, that's 0 to 90 degree in 4 quarter parts. So center of the pivoted magnetic needle, that center is the center of the coil, that coincide with the center of the coil. So see that compass, that magnet and the coil is parallel to each other. That magnet and coil is perpendicular to each other. The aluminum needle shows the deflection of 0, 0. So the magnetic needle shows the deflection of 0, 0. And aluminum needle is 90, 90. And 3 turns are there, 2, 5 and 50. 3 turns are given. That means it's depending on the number of turns in the coil. You can connect 2 turns, 5 turns or 50 turns. So using that screw, we can connect the 3 things. And now theory. So plane of the coil. So the coil, it is placed in the parallel. So earth magnetic field BH is acting like this. This is the earth magnetic field. So earth is a magnet, earth behaves like a magnet. So it's a earth magnetic field. When the current is flowing through the conductor, that coil, that magnetic induction is produced. That magnetic induction is perpendicular to the earth magnetic field BH. So the two fields are perpendicular to each other. So the two fields are perpendicular to each other. In that field we are placing the magnetic needle. So the magnetic needle will come to rest in the direction of resultant of two forces. So according to the Bayer-Savart law, B equal to BH tan theta. If I is the current passed through the coil n number of turns and radius A, the magnetic induction at the center of the coil is the next equation. See that Ns is the magnetic compass. BH and B are the two cross fields. Now you see that B equal to mu naught Ni by 2A. That is the magnetic induction produced by the coil. Substituting that equation 2 in 1, we can equating the two equation. You will get mu naught Ni by 2A equal to BH tan theta. Okay, two sides are B there, so equating the two values. Our current I equal to 2A BH by mu naught tan theta, or I equal to K into tan theta, where K equal to 2A BH mu naught N. So instead of that value, we are substituting the value K. That K value is called the reduction factor of the tangent galvanometer. It's a constant at a place. Using this equation, current in the circuit can be determined because I is the current. I equal to, we know the formula. So using that we can calculate the current. But the galvanometer is most sensitive, the deflection between the 45 to 45 degree. Exactly 45 means it shows the perfect deflection that is sensitive in that 45 degree. The deflection has to be adjusted between the 30 to 60 degree. So the distance that shows the galvanometer aluminum needle இருக்கு இல்லையா, அதோட deflection எப்பவுமே நம்ம from 30 degree to 60 degree இருக்கிற மாதிரி பார்த்துக்கணும். ஸோ இதான் வந்து பார்த்தீங்க அப்படின்னா galvanometer. So galvanometer அப்படிங்கிறது it's a very important question. Okay. Then next we are going to see the properties of the magnets. So what are all the properties it possesses the magnet? So magnet has the large number of properties. So first one, magnetic intensity. Magnetic intensity or magnetizing force, that is denote the letter H. So magnetic intensity at a point is the force experienced by the north pole of unit pole strength placed at the point due to pole strength of the given magnet. So magnetic intensity at your point. Intensity na enna evlo dooram anoda magnetic வந்து field இருக்கு, strength இருக்கு அப்படினு calculate பண்றது. There is a force experienced by the north pole of unit pole strength placed at that point due to pole strength of the given magnet. That is equal to H is equal to B by mu. It is also defined as the magnetomotive force per unit length. It can also be defined as the degree or extent to which the magnetic field can magnetize the substance. So எவ்வளோ தூரம் நம்ம எனர்ஜி ஸ்பெண்ட் பண்ணால் அது மேக்னெட்டாக மாறும் அப்படிங்கிறதும் என்னது மேக்னெட்டிக் இன்டென்சிட்டி ஆர் மேக்னடைசிங் ஃபோர்ஸ். ஆர்டினரி மெட்டீரியலை மேக்னெட்டாக மாற்றுறதுக்கு நான் எவ்வளோ ஃபோர்ஸ் யூஸ் பண்ணோம் அப்படிங்கிறது. இட் கேன் ஆல்சோ பி டிஃபைன்ட் ஆஸ் த ஃபோர்ஸ் எக்ஸ்பீரியன்ஸ் பை த யூனிட் பாசிட்டிவ் சார்ஜ் flowing with unit velocity in a direction normal to the magnetic field. So force experienced by a unit positive charge flowing with unit velocity, the direction normal to the magnetic field. That is also called the magnetic intensity. The SI unit of magnetic intensity is ampere turns per linear meter. So ampere per meter. Its CGS unit is Oersted. So Hans Christian Oersted is the name of the scientist. So CGS system, its unit is Oersted. So magnetic field strength or magnetic field or magnetic induction or magnetic flux density. So magnetic flux density is the number of magnetic lines of force crossing through a given area or lines of force passing normally through a unit area is called magnetic flux density. That can be written in P equal to mu into H. Its unit is Weber meter power minus 2, or you can write Tesla. Here CGS unit is Gauss, or 1 Gauss equal to 10 to the power minus 4 Tesla. Next thing is magnetic flux. So magnetic flux is defined as the number of magnetic lines of force passing through normally through a surface area. So எவ்வளோ magnetic lines of force pass பண்றோம் ஒரு closed surface area குள்ள, that is a magnetic flux. Electric flux, electric field அப்படிலாம் நம்ம பார்த்திருப்போம். அதே மாதிரி தான் இதுவும். இது magnetic flux. So magnetic flux means what is the number of magnetic lines of force passing through a given area or normal to the surface area. That is called magnetic flux. Its SI unit is Weber. So what is the relation between B and H means B equal to mu into H, where mu is the permeability of that medium. So next we are going to see the magnetic permeability. So magnetic permeability. So permeability means it is the degree or extent to which the magnetic lines of force can pass enter a substance. So ஒரு substance இருக்கு, அந்த substance குள்ள எவ்வளோ magnetic lines of force குள்ள pass ஆகுது, இல்ல the substance how much it allow the magnetic lines of force to passes through it. That's called permeability. எவ்வளோ தூரம் உள்ள pass ஆகுது magnetic flux அப்படிங்கிறது தான் இதோட permeability ன்னு சொல்லுவோம். The unit is Gm or ampere inverse 1, Weber ampere inverse 1, meter inverse 1, or Henry meter inverse 1. Relative magnetic permeability. So it is the ratio of magnetic flux density in a material to its vacuum. So relative அப்படினாலே you have to relate the two values. One is the, it can define as the ratio of absolute permeability of the material to the vacuum. So vacuumல அந்த மெட்டீரியல் இருக்கும்போது அதனுடைய permeability எவ்வளோ, அந்த மெட்டீரியல் நம்ம என்ன மீடியல் வச்சிருக்கோமோ அப்போ அதனுடைய permeability என்ன, ரெண்டுக்கு நடுவில் இருக்கிற difference. So the ratio between the absolute permeability of the material to its vacuum. The intensity of magnetization. It is the degree to which the substance is magnetized when placed in a magnetic field. ஒரு substance கொண்டு போய் magnetic fieldல வைக்கும்போது how that substance are magnetized, how much or how quick that substance are magnetized. அதை என்ன சொல்லுவோம் அப்படின்னா the substance magnetized when placed in a magnetic field. That is called intensity of magnetization. எவ்வளோ ஸ்ட்ரென்த் இருந்தா அது அவ்வளோ சீக்கிரம் வேகமாக பண்ணியிருக்கோம், மேக்னெட்டாக கன்வெர்ட் பண்ணியிருக்கோம் அப்படிங்கிறது தான் magnetization. It can also be defined as the magnetic dipole moment M acquired by unit volume of the substance. அப்படின்னு சொல்லலாம். Or it can also be defined as the force strength per unit cross-sectional area of the substance. Or I is equal to M by B, or I equal to M into 2L. These are the relation between the equations. Okay. So I equal to, instead of M you can write M into 2L. Divided by volume you can area into 2L. That's why writing here. So M by A. So the two values are cancel each other. So I is equal to M by A. So that is I equal to M by A is here. The SI unit of intensity of magnetization is ampere meter inverse. So next thing is magnetic susceptibility. These are all the things are very important. It is property of the substance which shows how easily substance can be magnetized. இங்க எவ்வளோ சீக்கிரமா மேக்னெட் பண்ண முடியும் அப்படிங்கிறது intensity of magnetization. எவ்வளோ சீக்கிரம் ஈஸியா சப்ஸ்டன்ஸ் வந்து மேக்னடைஸ் ஆகும் அப்படிங்கிறது susceptibility. So it is the property of a substance which shows how easily a substance can be magnetized. It can also be defined as the ratio of intensity of magnetization I in a substance to the magnetic intensity H applied to the substance. So ratio of intensity of magnetization. நம்ம மேக்னடைசேஷன் பண்றதுக்கு எவ்வளவு ஃபோர்ஸிங் அப்ளை பண்றோம் மேக்னெட்டிக்கா இன் எ சப்ஸ்டன்ஸ் டு த மேக்னெட்டிக் இன்டென்சிட்டி, அதனுடைய ஸ்ட்ரென்த் எவ்வளவு, இன்டென்சிட்டி எவ்வளவு, ரெண்டு நடுவில் இருக்கிற ரேஷியோ தான் என்னது சசப்டிபிலிட்டி. தட் இஸ் M equal to I by H. So we can relate the permeability and susceptibility. So the relation between the magnetic permeability and susceptibility is mu r